Hello, my name is Nur Akila binti Osman. My metric number is 304907. Today I want to explain about the introduction of this project. Hashing is a fundamental and efficient technique in the field of data structure, employed to enable fast storage and retrieval of data. It operates by applying a hash function to a given search key, converting it into a specific index within a fixed size hash table. This method allows for constant time complexity on average for operations such as insertion, deletion, and lookup, making it highly suitable for use in various real-world applications, including database indexing, memory caching, and search engines. The primary goal of this assignment is to develop a hashing program that accepts user-defined input, specifically the size of the hash table and a set of search keys. Each key is processed through a hash function to determine its appropriate index in the table. However, due to the limited size of the table and the possibility of multiple keys being mapped to the same index, collision may occur during the hashing process. To handle such a case, the program implements two widely recognized collision resolution strategies. The first one is open addressing, a method in which upon occurring a collision, the algorithm searches sequentially for the next available slot within the table. The second is separate chaining, a technique where each index in the hash table maintains a linked list or dynamic array to accommodate multiple keys that hash to the same index. In addition to executing the hashing process, the program provides a comprehensive step-by-step explanation of the hash conclusion and the procedure used to resolve collision. It then presents the resulting hash table generated by both open addressing and separate chaining. Through the assignment, students gain practical insight into how hashing algorithm function and how different collision resolution strategies influence the organization and efficiency of data storage in hash table.
Assalamualaikum, my name is Alia Safia and my metric number is 305604. So today I am going to explain what does this program does. This Java program demonstrates how hashing works using two common methods, which is open addressing and separate chaining. The program starts by asking the user to enter the size of the hash table and the number of keys they want to insert. Then, it takes each key and stores it in the hash table using both methods, one after the other. The first method is open addressing. In open addressing, if the calculated index is already full, the program checks the next index one by one until it finds an empty spot. Next is the separate chaining. In separate chaining, the program allows multiple values at the same index by storing them in a linked list at the index. After all keys are inserted, the program displays the final hash tables for both methods, so the user can see how the values were stored. This project is useful for learning how hashing works and how different collision handling techniques behave in practice. That's all from me. Thank you.
Next, let's talk about the output of the program. First, the user is asked to enter the size of the hash table, which is 5, and then to insert 4 keys, which are 78, 99, 52, and 81. Using a simple hash function key for 5, the program calculates the initial index for each key. Key 78 gives index 3, key 66 gives index 1, key 52 gives index 2, and key 81 also gives index 1. In the open addressing section, key 78 is inserted at index without any problem. Key 66 is inserted at index 1 and key 52 is inserted at index 2. However, when key 81 is inserted, it causes a collision because index 1 is already occupied by the key 66. The program then checks the next index, which is 2, but it's taken by key 52.
then index 3, which is taken by 78. Finally, it finds index 4 to be empty. So, key 81 is placed there. The final hash table using open addressing looks like this. Index 0 is empty, index 1 has 66, index 2 has 52, index 3 has 78, and index 4 has 81. In the separate chaining section, keys are inserted into list and each index. Key 78 is inserted into list at each index. Key 78 is inserted at index 3. Key 66 is insert. It also maps to index 1, like key 66, but instead of probing other indices, it is out to the same list at index 1. The final hash table using separate chaining is as follows. Index 0 is an empty list. Index 1 has the list 66, 81. Index 2 has 52. Index 3 has 78 and index 4 is an empty list. This shows the difference between how the two methods handle collisions, open addressing, search for a new slot, while separate chaining groups collide values in a list at the same index.
Hi, my name is Nur Shatira and my metric number is 305766. Let's see our conclusion.
This project has significantly enhanced our understanding of hashing and collision resolution strategies, key topics in data structure management within the field of information technology. By developing a Java program that implements both open addressing and separate chaining, we explore how different methods behave when multiple keys map to the same index in a hash table. This helps us understand the practical differences in terms of memory usage, efficiency, and performance. Through the insertion of user-defined keys and observing how each technique handles collisions, we learn how open addressing probes for the next available slot, while separate chaining groups collided keys into a list at the same index. This hands-on implementation reinforced our theoretical knowledge and allowed us to see the real-world importance of designing effective hashing functions and choosing suitable collision resolution strategies. In addition, this group project enhanced our problem-solving, teamwork, and programming skills, particularly in Java. It encouraged us to collaborate effectively, think logically, and test our code thoroughly. These skills are important not only for academic success but also for future roles in professional IT environments. Overall, this assignment was a valuable experience that prepared us for more advanced applications in data structure and software development.
And this is our source code.